Hello IB, here we are looking at 11D. This section's on the double angle formula. It starts off with this investigation where we see what sort of results we get when we look at an angle and it's double angle. So in the table setting up here, what I'd like you to do is have a go at filling this in. Use your calculators. So for these angles, see we've got 0.631. There's no degree sign, so that tells us we're in radians. And if it's 0.631 and pi is 3, so we've got, we're not even 1/3 away around half a circle, so we're somewhere in quadrant 1. So that must be quadrant 1 somewhere. Find a pen. So you should be able to look at that and go, right, we're in quadrant 1. This one here, also in quadrant 1, but we're in degrees, so you'll need to change your calculator. And this here, we're minus 3.697, so that means on a unit circle we've gone backwards. 3.67 is more than pi, so we're somewhere back here in quadrant 2. Alright, so if this is theta, we're taking sine of 2 theta, that means we're taking sine of 2 times 0.6318. So what I'd like you to do is pause the video, use your calculator, calculate sine of 2 times that, then 2 lots of sine of this angle, then 2 lots of sine of the angle, cos of the angle, then cos of double the angle, then 2 times cos of the angle, and then cos squared of the angle, in other words, cos of the angle squared minus sine of the angle squared. So stop the video, have a go, fill all that in, or if you haven't been working with someone, you can share it and take turns at filling it in. And then come back and we'll look at the results. Okay, so hopefully you've got that done. And what we see is when we fill in these, we come out with all these different values. And what we've noticed here is sine of 2 times the angle is matching up with 2 times sine theta cos theta. So that's giving us the same value. So it looks like sine of 2 theta is the same as not 2 times sine, but 2 times sine theta cos theta. In this case, if we take cos of the double angle, we get 0.304, and that turns up again when we take cos squared theta minus sine squared theta. So we can see this relationship is true for these 3 angles. And since they're quite random angles, it's more than likely it's going to be true for all angles. So we come up with this relationship, these relationships. Sine 2 theta is equal to 2 sine theta cos theta. And these are in your formula booklet. We also see that cos 2 theta is equal to cos squared theta minus sine squared theta. But remember, we can rewrite these using that Pythagorean relationship. So remember that sine squared theta plus cos squared theta equals 1. So that means sine squared theta equals 1 minus cos squared theta. So we could substitute that into here and we end up with cos squared theta minus 1 minus cos squared theta makes a plus cos squared theta. So that then gives us this relationship, 2 cos squared theta minus 1. The same as we could switch that one around, and let's just do that one. So we could go cos 2 theta equals, and instead of cos squared theta, we could write 1 minus sine squared theta. So that's this part here. Then we go minus sine squared theta. So overall we end up with 1 minus 2 sine squared theta. So that gives us this relationship. So in other words, these are just the same identity, just written in different forms. What I'd like us to do in class is actually look at this part of the investigation, which is a proof that we can show these relationships are true for all angles. But I'll leave that and we'll do that one in class. But let's use these identities and see how they work. So here's sine of pi on 3. We can work out sine of pi on 3 already because we're good at our triangles. But let's work it out using this relationship. So sine 2 theta is 2 sine theta cos theta. So in other words, this is going to be the same as taking 2 lots of sine. Now, if this is our theta, our 2 theta, 1 theta will be half of that. In other words, pi on 6. 6 cos pi on 6. So think back to your triangles. That's a funny shape, bit of a leaning chop, must be the Leaning Tower of Pisa triangle. Okay, so in here we've got our pi on 3, pi on 6, which is our 30 degrees, 1, 2, root 3. So this is going to be the same as 2 times sine of pi on 6 is a half, and cos of pi on 6 is root 3 over 2. Alright, so 2 times the half cancels and we get root 3 over 2. And is that the same as sine of pi on 3? Sine opposite of a hypotenuse, it's true, which doesn't surprise us. But that's a way we can work it out. So remember, if this is our 2 theta, this value is half of what we had here. Let's do another one of these. We'll do it in degrees. Cos of 160, that's going to be the same as cos squared, half it, 60 degrees, minus sine squared, 60 degrees. Cos of 60 from our triangle is going to be 1 over 2. So we've got a half squared minus sine of 60 is root 3 over 2. Root 3 over 2 squared. So we have half squared is a quarter minus 3/4 gives us minus a half. Okay, is that correct? So let's think. Cos 120, that's in quadrant 2. So in other words, we've got 60 degrees in quadrant 2. That's the reference angle of 120 degrees. Our ASTC tells us that cos in the second quadrant is going to be negative. So that's our negative. Cos of 60 is going to be 1 over 2 from our triangle. So correct. So obviously you wouldn't go through that proceeding to work it out. This is just using the formula in an example that we know how to check the answers correct. So let's look at ones that are not so straightforward now. Here we've got sine x is minus 2/3 and x is between pi and 3 pi on 2, and we want the exact value of sine of 2x. So our relationship says sine of 2x equals 2 sine x cos x. Alright, now we know sine x is minus 2/3. It's negative because we're in, which quadrant is this? If we're between pi and 3 pi on 2? Hopefully you've guessed that. It's quadrant 3, which explains why our sine is negative. So let's do our triangle. If this is our x, and we've got opposite over hypotenuse, it's not a unit circle in this case, so let's call this just an a value. So we now know that 3 squared equals 2 squared plus a squared. So a squared equals 9 minus 4. So a is going to be plus or minus root 5. I've jumped a few steps. So 9 minus 4 is 5, square root. Obviously we can't have a negative, so a must be equal to root 5. So now we can substitute in here. So we're going to have 2 times sine x is opposite over hypotenuse. And we've got 2/3, and it's negative, remember, because we're in quadrant 3. Quadrant 3 for cos is going to be negative also, and it's going to be root 5 over 3. So therefore that is equal to positive, what have we got? 2 times 2 is 4. 4 root 5 all over 3 times 3 is 9. Can't simplify that any further. So that gives us the exact value of sine of 2x. This one here, if x is acute tells us which quadrant? Quadrant 1. And we know cos 2x is minus 7/9. We want to find cos x and sine x. Alright, so cos 2x, we know that that relationship is cos of 2x equals cos squared x minus sine squared x. But we don't know what sine squared x. We've got cos of 2x, and we want to find these. So we don't want two unknowns. Oh, we need an x in there. So let's turn this into just one unknown. Remember back at your relationships? Let's just use one of these, and it doesn't matter whether we use this one with just sine squared theta or this one with cos squared theta. Anyway, let's use that one because it's going to give us, we'll start with a positive value. So we're going to go, that is equal to 2 cos squared x minus 1. So now we know that minus 7/9 equals 2 cos squared x minus 1. Alright, back to some basic algebra. Add 1 to both sides. So we have 2/9 equals 2 cos squared x divided by 2, more space. So 1/9 equals cos squared x, square root both sides, and remember if we take the square root we're going to do plus or minus. So now we can see that cos x equals plus or minus 1 square root of 1 on 3. Alright, let's have a look. We're in quadrant 1. Okay, so does that mean, can it be negative? No, because everything is positive. So in quadrant 1, therefore cos x equals 1 square root of 1 on 3. Okay, another way of writing that is 1 over root 3. Now, it looks a bit like our triangle, but we don't get any cos values with 1 on the root 3. So we need to make up our own triangle. So here's our x. Cos is 1 over root 3. See that diagonal? We didn't have the hypotenuse equal to root 3. So we need to do our Pythagoras again. So a squared plus 1 squared equals root 3 squared. So a squared equals 3 minus 1. A is equal to square root of 2. So 3 minus 1 is 2. Take the square root. So I am jumping a few steps here. Alright, so cos x we now know is 1 on root 3. And this is, what do we say, equals root 2. So now we can say that sine x equals root 2 over root 3, and you could also write that the square root of 2/3. So have we answered the question? Yes, we found cos x and sin x. So there's our sin x answer. And our cos x was up here. Alright, so some important relationships here. We've got some other examples, but we'll have a look at that one in class. So thanks for listening. Make sure you make some good notes on this and come with any questions you have for class. Bye for now.